Oh,
Okay. Yeah. Now go ahead.
my questions are specific to the discussion. I have a few different questions. Is there a minimum word count for this assignment for the discussion?
Yes. So good question, Stephen. Yeah. So basically, this question is related to layoff, which is happening, and you can see the data that is recorded on that website, layoff.fyi something. So, this is happening probably not only in tech industry, this is related to high tech industry, which is there. So high tech industry is, and what are the reasons? Basically, you need to come up with the numbers, you need to come up with the model, and you need to being a manager, being a management expert, you need to come up with reasons, logics, and why this is happening. Because we are not limited with the numbers on the top of numbers, we have to come up with the some findings, some reasons, some logic, some insight from the industry. So, you can make about 200 words of writing, but the experiment that you are going to do, I can talk about that. So 200 words is sufficient if you come up with some logics and something. If you want to explain more, feel free to, write more, no problem. But minimum 200 words. And apart from that, data and method of validating the model.
I appreciate that. Yeah, I think I'll beat 200 pretty easy. My question though is you just stated that we would be speaking about the IT industry. My industry is property management, and I thought my understanding of the assignment was we were going to create predictors that
Yes.
led to the response for our industry. So I built 7 predictors for property management layoffs. Was that correct to do?
Yes, yes, that's perfect.
Okay.
So actually, I have this database which reports only high tech industry or technology industry like Facebook, like Google, IT, and related. But if you are working, let's say, property management or real estate agency or real estate industry, you can come up with that, because that industry is also going through a lot of changes, because whatever phase it has experienced in last 4 5 years after COVID, it is no more like that. It is going through a lot of ifs and buts. So you can do that.
Okay. And so for our predictor data, is it predominantly going to be Likert scale uh, data so that we
Yes.
may dummy the information on a scale of
Yeah. So
1 to 5? Okay.
yeah. So this is your very good question. Let's say you don't have the real data. Let me go on the whiteboard to explain your doubt. And
Yes, that's a
yeah.
good question because I was gonna ask about the same kind of thing about the
Okay.
um yeah.
So for example, let's say uh, this is the situation of let's say real estate industry. And Stephen, what is your outcome? What is your outcome variable?
The outcome would be number of layoffs.
Number of layoffs. And what are your predictor?
My predictors are revenue growth,
A plus B, revenue growth. Okay. Plus C,
economic economic conditions.
economic condition. Let's say, I'm just making a rough plus. Let's say you have 3 4 more predictors, because
Sure.
all are contributing in layoffs in real estate industry. Let's say number of layoffs, you can also decide here number of layoffs on 1 to 7 point Likert scale. Let's say 1 to 7 point. You go to your friend who is also real estate person, ask, what do you think on 1 to 7 point scale? Uh, Here you can give the intensity. And not at all. 7 is high likely there will be layoffs. So 1 to 7 point, you ask them what is the chance of this. Here A is this, B is this RG. RG, you can also ask him, okay, 1 to 7, what do you think about RG? Where 1 is least, 7 is most. Similarly, economic condition, you can ask 1 to 7 and other predictors also. So you can make the table, you can make the data. So, this is dependent variable, layoffs. Then, you can go on different, and then you can run your model and you can see which is the significant predictor. This is this economic condition, which are the contributing factor for layoffs. And, this model will clearly give you if people think clearly and if there's a clear data. So for example, first response, let's say somebody is giving 5 here. In this case, they are giving 4 here. They are giving, let's say, 6. And going on, you can do this data for, as you can see, maximum numbers or higher the N is better for normalization, better for results. But, whatever number you can get, that would give you real insight. Let's say you get, 30 plus. Basically, you can get some significant outcome. But if you get, let's say 5 or 10, let's say 10, probably they may be biased. Probably, you will not get a good results, or whatever you are expecting may not reflect in 10. But, so higher the amount of the responses you can get on Likert scale would be good. Is it making sense?
Yes, appreciate that. The part of the number of layoffs being part of the Likert scale was very helpful. I didn't know that at the time. I just had 2 other questions related to the discussion. Are we expected to have 2 responses to classmates? And go ahead.
So let me answer your question this first. So actually you are carrying out this experiment. Let's say you are doing for real estate. Now, you have made this discussion over there on the website, on the discussion forum. If somebody else is in the real estate and he feels okay, I mean, seems, some extra inputs are important. Whatever predictor you have, maybe he can add or she can add one more, or she can say, or he can say this is not important. So not necessary. But if you contribute, it would be great. So this is the, not hard and fast, but if you do it, good. Means I will not judge, I will not look into that. But it is for peer learning. Yep.
Understood. And my last question was, I'm generating all of the information for this discussion based on my own professional expertise, and I'm not using any outside information. So is it okay that on this assignment, we do not have references or outside references?
Yeah, that's perfect. That's perfect. If you are doing your own, yeah, that's perfectly, no problem.
Okay, thank you.
You're welcome.
Professor?
Yes, please.
Hi, good evening.
Good evening.
So that was some interesting questions, and it was kind of more related to what I had. So I'm in the accounting profession on the construction field. So I kind of looked in the Bureau for Labor Statistics in the U.S. Bureau, and I found the data for the layoff in the professional and business services. I did look at professional and business services include accounting. Is that a good data to or should we use more companies?
I mean, if you get some data which can help you to generate the model and that is available open source somewhere openly, 100% use it.
Yeah, I think that's a good data. I just wanted to confirm.
It has sufficient predictor, or means it has sufficient inputs, or means
I got a year. Do you recommend getting more than a year of data?
No, basically this is, if you see the regression modeling, we have cross-section data. So basically this is, you know, the difference between a time series data. Is it time series data? It is, or is it cross-section data?
I'm not sure what the
So like,
question,
you know,
sorry.
we just spoke with Stephen, you know, this is cross-sectional data. Means, let's say you, one person and, you know, his choice, his inputs on 7 different variables, that is cross-section. But yearly, you know, a time series data, you have, you know, for example, this is time series 1970 to, let's say, you know, 2024. So when you see this kind of data, this is called time series data. And
Okay.
that will help, you know, for forecasting, you know, future, let's say, over a period from 1970 to now, in whatever area you have this kind, till now, what would be the, you know, situation future on, from this point onwards. So this will be helpful trend analysis, forecasting. So to be honest, I don't know what is the data, but if you have cross-section data, next module we will do the forecasting, and we will, you know, we will do similar thing like a stock price prediction, or you know, trend analysis of, let's say, Nvidia or Amazon or Goldman Sachs, or so we will
Yeah,
do.
these are the layoffs depending on the business and professional services. So, and then my factors, it was kind of a similar question as Stephen had, because I was looking for the data for my factors like revenue growth, technology advances, demand for accounting for like its services, or the time factors of the year, because depending on the time of the year, it's when they demand more services. But it was kind of hard for me to look for that data, but I saw the LinkedIn scale. So let's say if I get my some of my colleagues to give me the scale for my factors, how do I get the mean of all those numbers?
How do you get the mean? So to be honest, if I am understanding, you have a year, you know, in different months or different weeks or like that for particular year, so you can average out. Or I mean, if you can share the data, I can give you my input, but without seeing the data, I mean, only understanding this is more about, we are not dealing a time series data. We are dealing with cross-sectional data to make the
the correlation model. I'm trying to
regression.
predict, right?
Yeah, so correlation is first step to go for regression. So basically we are doing a regression, which are the significant predictor and which are not significant predictor in your model.
Correct. And first we have to get the Y and the X.
Yes.
Here in the Y are the numbers of layoffs in the professional and business service industry. And my X will be the factors that influence the layoffs.
So you have only one X, or you have X1 or X2 or X3?
I have 7X.
Oh, perfect. Then yeah, let's go ahead, like, you know, B, C, X2 plus, you know, D, X3, and keep going.
Yeah, for professional services like revenue growth, cost saving, government regulations, demand for the services, the company size, the time factors. But what I'm saying is the data, I did get it from the Labor Statistical Bureau, which they have all the numbers of layoffs for that professional and business services pertaining per month. So I'm just going to use the number of layoffs and the X on my X's.
Okay.
But then my question was, since you mentioned sorry, if I'm not pronouncing it correct.
Likert scale.
Likert scale. Sorry.
Or maybe my pronunciation may not be.
No, it's okay. I don't need
it's called Likert.
Likert.
Likert scale. Yeah, sorry.
Well, the scale, if I get, let's say, if I get to get the scale for to few of my colleagues and give me a point from 1 to 7 or 1 to 5, should I use both of my colleagues combined, or how should I combine them together?
So okay. So first thing, if you can get real data, like you are talking about Bureau of Labor Statistics, fine. See, many students, I don't have real data, so in that case, you can come with, we have in class about 200 students, and in 200 students, you can ask their opinion in order to and getting their opinion, how do you get? It's 1 to 7 Likert scale. So basically, first step, let's say, what I have given you, it's number of layoffs. So for examples, one company has 200 layoffs. So this is layoff and equal to, so this is, by, then there you can go on the company Wikipedia profile or company secondary, and they have revenue growth. For example, they have, investment in AI. They have different factors, therefore they are, layoffs. So please, get the real data from, let's say, Facebook laid off 2,000 or more than 20,000 employees. What is the revenue growth of, it's a negative or positive 10%, let's say plus 10%. How much they are putting in their investment in AI, let's say $2 billion, something like that, for example. Other factor, and similarly, you can go for different other companies like Google, like Expedia, or different other IT companies like which they are doing layoffs. So 10, 20 companies, and search this data from their secondary sources. They have different reports available online, and they have to do mandatory because rules and regulations. So once you do for like Google, Facebook, LinkedIn, or X, or see all different, and once you do this, you are able to generate a model. So this is first thing. If you are not able to do second thing, like you said, you have a labor statistics data, use that. If you don't have that, the last option is Likert scale, that you can make Likert scale. You can ask your friends, your colleague, whom you talk, just ask
But
five, six questions and take their input and run the model.
But isn't the Likert scale used for the factors, not for the Y variable?
Also for Y variable, if Y variable is there, Y is dependent variable, you can do, it's up to you how you design your experiment.
Okay, because the data that I get from the US Bureau of Labor Statistics, then if it's not, then that data might not, then I will have to get either some factors away, because in the data from labor statistics, it gives it to me by the total numbers in that specific industry, in the professional and business service. It doesn't give it to me by company.
Okay, I mean, that industry is fine. So if you have, let's say you have 5 industries, it's a manufacturing industry, or services industry, or agriculture industry, or aviation industry. Think about, all this food services, or different industries. Okay, you can make industry-wise. You can make industry-wise data, model. Different industries, you can take it.
And then the revenue growth, and then the technological advancements, I can do it by the industry.
Yeah, you can do industry. So it's all up to you how you design the experiment. Like, real estate is one of the industry. And services industry, hotel industry, education industry. There are many industries which are contributing to the economy.
And if one of the factors require the Likert scale, we provide the data. Let's say a colleague of mine did it. We just say, oh, I have this data from a colleague of mine.
Yeah, I mean, you can tell me. you can write, yeah, this you have done the experiment, or this you have collected from your friends, your family members, or
Okay.
so no hard and fast. Purpose of this design is you can learn how to do this experiment by yourself. If you come across any situation, you are able to handle this situation using numbers.
Okay. Another quick question.
Yeah, please.
So I was looking at the video, the recorded video from the previous class.
Yes.
So if I'm understanding correctly, so once we do the regression analysis and we find the useless and useful,
Yeah.
depending on the p-value, we go to the predict and input the useful variables?
No, so basically I can explain that part. I have some data right here. So
Okay.
basically, give me 5 minutes. Once I will, these things are done.
Okay,
I will explain this experiment, or let me explain then, just a minute. So
no problem. Thank you.
Wait a minute. So I can show you one experiment that can answer many questions. So 1 minute.
Yeah, because I didn't know more or less the difference between the correlation in the Bayes stacks or the fit regression model in the regression. Is it like
Yeah, just a minute. Okay. Can you see my Minitab?
No, I only see there you go. Yes. Now, yeah.
Okay, everyone can see. So basically,
we can see it now.
Okay, perfect. So basically, this is like a real data from, as you know, this is the time that many international students join US universities. And about more than 300 or 400,000 students come every year. New students come every year in United States. A major part is from China. The second largest students come to US university from India. And and what is their chance of admission? So chance of admission is dependent variable, which is right here. These are individual, these are predictor. Their GRE score is another important factor that contribute in their admission in. English language score is another thing. University rating in USA, they give 1 star, 2 stars. So this is a university rating. They also, US university also needs a statement of purpose, means a letter that why you want to join university, what is the purpose and all. This comes under letter of recommendation. A US university also need letter of recommendation from different, professors or your professional reference. And then GPA. In here, we have 0 to 4. On 4-point scale, we have GPA. In India, it's all 10-point GPA. So 9.65 is on 10-point GPA. This is research university is 1 and non-research university is 0. Like Eastern Washington University we are in, it's a teaching university. So it's a non-research university, but WSU, Washington State University, University of Washington, they are research university. So this is the data of 500 students I collected. And, this is a real data, not me, but I got from, some of the sources. Now, the question is that I have many things. So let's say somebody would like to apply for next year. Based on this data, I would like to make a model, and somebody has TOEFL score, GRE score, and would like to know what is their chance of admission to get into the US university. I would like to make that model, and I would like to tell or guide him how I can do, because I would like to see what is the what is the likely chance of admission and all. So let's do. So basically, I go under this statistics. Are you following me? And let's say here regression. So basically, we are using fit regression model. What we are doing, only this option. We are not covering logistics, binary, and different model. The reason is different because we would like to cover the concept. We would like to cover the common thing. These are more complex. We have 6 weeks time. So just fit regression model. Okay. Now here you see chance of admission I put here. Continuous predictor I put GRE score. This score, university rating, statement of purpose, letter of recommendation, GPA, and research. So I put, I think, all model, all variables here. Now I go under OK. Now here you see, and
Professor, shouldn't research go in the since it's a binary like 0, 1
yes,
variable?
very good question. I wanted to cover, but after this, yeah, I will cover.
Sorry
So,
for jumping the gun.
Yeah, so yeah, this is because you have different, so it can go into that categorical variable. Will explain. So here you look, this is the model which we get it. Now we want to see which is the important predictor, which is the important predictor in the chance of admission. So here, this is the model. Let me make little bit bigger. Okay, here you can see. Now this model looks, if I have a student whose GPA is this much, whose GRE score is this much, whose this, I can tell this is your chance of admission in getting in US university. Perfect. But I would like to see which is playing important role in chance of admission. How I can see? So basically, there is a simple hypothesis for predictor. So one is useless. Null hypothesis is all predictors are 0. Predictors are 0. Sorry, I'm not able to write because of mouse. Are 0, or in other simple word, I can say useless. If all are 0, that means only this part will, whatever value you will put for different variables, the chance of admission will remain same. But here H1 says, alternative says, at least one predictor, at least one predictor is non-zero or useful. Now look into the same principle that we looked into the last class. We are going to use the same concept. So here you can tell which is the predictor, H0 and H1. Again, alpha value and p value, we are going to use the same principle. So alpha value is by default is 5%. What are the p values here? Which is useful predictor? Which is useful predictor?
All of them except the university rating and the SOP?
Yeah, so perfect. So because this p value is more than alpha value, which is 11% or almost 12%. So which is higher than, so this is useless. Okay. Oh, sorry, useless. Please bear with my handwriting. I mean, this writing and SOP. These two are useless. And I will show you, demonstrate you. Rest all are useful. Because so useful and useless. So these two are useless and rest are useful. Okay. So now we got our model and we see, if somebody does very poor statement of purpose or, apply to different rating, that does not matter in admission. Rest are matters. Rest variables are matter. So look into why I'm saying, because we can experiment, we can see this. Okay, so now look into stat regression model, and here we have the predict. So this option only appears when you run the model first. So we run this model first. This is the model, then we can do the predict. First step you can't do. First you have to train this machine. What is your model? Now we are going to predict. Now here you see two scenarios. Number one scenario, GRE is, let's say, 300. 300 in both cases. I'm just taking two cases. TOEFL score is same, 118 and 118. Sorry. University rating, I can give here 4. Here I can give least is 1. So I'm just playing with this. Statement of purpose, I'm just giving, let's say, 4 here, and here I'm giving 1. Letter of recommendation, I'm just giving same, which is 4 and 4. GPA is 9 and 9. And research is both, let's say, 1 and 1. And I think I defined all the variable here. Now I would like to see what is the chance of admission. What is the 2 factors I did? University rating and statement of purpose. I put one place maximum, other place I put is, least. Now see.
Those are make-up numbers, right?
Yeah, prediction means, I have 2 students, and one student has, GRE score this, TOEFL score is this.
Got it.
This is one student. Other student who did very poor statement of purpose, who did very, university rating is very poor. So same 2 students, but he did not consider these 2 factors seriously, and therefore he got 1 out of maximum, and here he got 4 out of. Now see what is the chance of admission in both cases. So here you can see this is the chance of admission, which is about 79%, and here it's about 77.4. So how much difference is when you have highest, excuse me, and when you have the lowest, these. So only 1.5, about 1.5 or about 2.5 difference, about 2 differences reflected when you have highest value. Therefore, these 2 predictors are not contributing significantly in the significant predictor in the model. Is it making sense? Now, your question is like, they go into the categorical variable. Very good. Yeah, correct. That's important. So, like,
Professor, I'm sorry, can I just interrupt really quick?
Yeah.
When you were entering in your figures into that table for the the GRE score, yeah, where did you access that in Minitab? I'm sorry, I was taking notes and I completely missed when you entered.
Where I got these numbers?
No. Where did you select in Minitab to get to the table and put in the numbers?
Okay. So basically, just a minute. So can you see this? This is, I shared right here. Can you see this PDF, regression, Minitab? And here you can see.
No, Professor, the PDF, it's not showing.
Oh.
Only Minitab.
Okay, just a minute. So screen 1. Okay, here we go. Can you see this, my screen?
Yes.
Yeah.
Right here, can you see this Minitab regression analysis PDF?
Yeah. Yes.
So when you open, you will get, complete instruction. However, I'm just showing here. So go under statistics, basic regression. Regression, and regression. And here you can see predict.
Perfect. Okay, thank you.
And I think I shared the screenshot when you look into the, okay, here you see. you can see the regression, and can you see this is the predict option?
Yes, thank you so much.
Yeah, so these slides are made based on the Minitab options. So you can see also, no problem. So yeah, this is what. So you can see the difference. When somebody scored least in these two variable or two predictor, the admission chances are about 2% less and 2% high.
Okay, that was going to be my question. So that means that because of it, they show in the regression analysis that they were useless, more or less. That's why, although that they have different scored in here, the difference is only 2% because they were kind of useless.
Yes.
Okay.
So, Professor, how university and SNOP or SOP are identified? Like, do they have weights or something?
Oh, so here you can see which is useful and
yeah,
so
got it.
This using p-value, useful. I mean, we know the null hypothesis is useless. Excuse me. Null is useless and alternative is useful. So basically, everywhere we need to keep those two things in mind, and we can understand based on p-value. Now here, this is R square. Somebody is asking about adjusted R and R square. What is R and adjusted R? R square is, so basically the reason, this is called coefficient of determination. R square is known as coefficient of determination. Means change in admission due to all these 7 variables. Change in admission due to GRE, TOEFL, university rating, SOP, LOR, all is explained by this R square. So 82.19% change in admission is due to these variables. So this is how we interpret. Means 82% change chance of admission depends on these variables.
Got it.
Okay, what is adjusted R square? So adjusted R square is, more refined, more purified, more filtered R square value. That is called by, because you see these two variables are useless in the model. Apart from that, if you look into, these are the, unusual observation from 500 observation that I took. These observations are unusual. Observation means maybe due to error, maybe some reasons. This is, out of the trend or something. So if you filter, one more time, you filter your things, you get little bit less. So R square adjusted is little bit lower value than this R square always. R square, this is another one, the Minitab gives, but usually R square, adjusted R square, this is more. So we don't talk, but these are the two. What is S? So basically overall, the results are deviated by this much, which is about 5 or 6% in this model. So standard result is deviated from this much. So this is the model summary. Now we come to what is the statistics of the regression model, entire regression model. So entire regression model statistics is F value that you can see. This is when you see regression is overall regression. So this value is, and this P value is, this model is. So you have to, so this is statistics and this is P value. And these are the same thing. This is TOEFL, this is, GRE, this is this that we looked. Okay. Now the question, and this is unusual observation that, these are going, maybe some data entry, maybe some reason. Somebody is having very good luck, or somebody evaluating and got the admission from low score or some. So these observations are unusual observations. So this is regression. Now there was a question that when we do regression model, whether those go into the here in categorical predictor, you are correct. So basically, as many as categorical predictor, input you can give, number of models will be more. So basically, for example, if let's say I just remove these. So here inversity rating is research. Let's say I just make here and I put research and non-research inversity. So there will be two models. So this is for research, non-research, this is for, so basically a same model, but for 0 and for 1. Similarly, we have state, other categorical predictor we can also make for that. However, I keep simply in this category that I included everything to, so there are two different models. If you make, different categorical predictor, you will have multiple models. So who asked this question? Can we put this? Yeah, this can be done when you are very clear what needs to be done. Which are the categorical predictor? I can clearly see research and non-research. These are the two universities category. And yeah, I can make two different models. And then you can do the different, but you can make a complete model and you can decide, you can predict based on the entry, values. So this is a regression. Yes. Who asked, am I able to answer your questions?
I have another question,
Please,
Dr.
please.
Vivetti. So on the fill in the blank, I sent you an email about this and you told me to ask in class. With it was asking for like the R squared adjusted. And so when I put that into fill in the blank, I meant to understand. So you would put like for 81.94%, you would put 0.8194.
Yes.
Okay.
So R square, if you look into slides and all, R square value is between 0 to 1 or 0 or 1. 1 means 100%, means 100% dependent variable is depend on predictors. 0 means no or anything in between. So let's say, yeah, so always keep in mind, always this value when you are entering in the this Minitab gives in this format. So 82.9 is 0.8219 because R square value is this. Our adjusted R, 0.8194. So 0.8194 always in this format because this is and this is giving. Another important thing that, you must notice, we are doing this regression. The correlation and regression, there is a significant difference. So a small r is correlation coefficient and R square is regression coefficient. What is the difference? So in simple regression, one dependent variable and one independent variable means only one predictor. R square, R square is R into R. You can clearly see when you do simple regression, means only one predictor, whatever correlation will be there, you multiply 2 times, you will get R square. Okay. So this is another, but in multiple regression, this is not the case.
Thank you.
You're welcome.
So I noticed on my mini tab that I don't have the assistant tab up right next to the help. This
is not available?
No, on mine it's not. I don't know if other people have it.
So are you
the web version?
You are using cloud version?
Yeah.
Probably it would be there. Let me check, I don't know, but let's see. So let's say Just a minute. Hope you can see my.
Yeah.
Because I think most of the functions are available as it is on the cloud version. Okay, so help and view additional tools. Yeah, the assistant. Yeah, I can't see here.
I don't know if it's helpful, but I used the virtual labs version and it was in there.
Yeah, virtual lab is exactly like same, your computer. However, you have to go through virtualization and 2-3 minutes it will load your desktop on your screen, and then you can do exactly the same functionality. So yeah, I'm sorry that it is not available here, but
okay. And the virtual, there's the instructions on there on the previous page you were just on, right? I'm pretty sure to.
Yeah, exactly.
Okay, cool.
Virtual lab, you can use all the softwares available with EWE using virtual computer.
Okay.
Means you can log in into the lab, like you go in university lab, and all the tools and all the things are available right there.
Okay. Okay, cool. Thank you.
Please.
Hi, I had a question about some of the one of the section exercises in the book. Are you able to answer a question about that?
Yeah, please let me know.
Yes, so it was section 13.19. So it was section in the 6 for nonlinear regression. And that first question just really stumped me. I got none of the answers that the answer key stated in the back, and I kind of just lost on how to do this one.
Yeah, so yeah, it's Melissa.
Yes.
Oh, so we are we are just learning only one technique. You can see, lot of things are there. So we have to make, for example, here you can see statistics regression. We are only learning one model. There are different other nonlinear. We are not learning nonlinear modeling.
Okay, so it's not necessary to learn every single thing in the book.
Yeah, so we are just learning PLS modeling and fitting model. So this is the non-linear thing we are not learning. In next module, we will learn little bit about different curves in predicting. So yeah, that is separate. We can if you come if you ask me after the course, or I can explain, no problem. But
no, it's okay. I don't want to waste anyone's time today. But yeah, that was just bothering me.
No problem.
Okay, thank you.
Just go for the simple modeling, simple fit model.
Okay, perfect. Great, thanks.
Any other question from the class?
Professor, sorry.
Yeah, please.
In your previous lecture, you went into stats and basis stats into correlation. What is the difference? And I saw the correlation there were different graphs between, pertaining in the data.
Yeah.
Is that also where we can see the regression analysis?
Yeah. So
or is just for the plots?
Correlation is, okay. In very simple layman term, correlation is relationship between two variables. Okay. Two variables. Okay. For example, Melissa, how you and we are, here, I'm instructor, you are a student. This is relationship in this course. Simple relationship.
Okay.
Or you, Melissa, you and Whitney, you are, taking same course. This is relationship that you did BADM 520 with Professor Dwivedi, and that's it. This is relationship that, yeah. Causal, the regression is causal relationship. Means it can cause you some impact. Let's say, if I get sick or something and I'm not able to conduct this meeting, then what happened? Probably you will not learn. So this is a causal relationship that, one variable affect other variable, which is causal relationship, and simple, and correlation is simple relationship, and regression is causal relationship, that one is impacting other, there's a reason, other, if there's a change in one variable, it will impact other variable. Is it making sense?
Okay, yes, 100%. Thank you. Thank you
You're
for that.
welcome. And how do we do, how to check whether this relationship is fine and not? So basically here is the option. Let me go with
So how to check that the regression has a correlation?
So basically, yeah, this is I'm showing you on the PDF also. You can see statistics basic, and here you can see the correlation, and you can select all of them. I'm just selecting all of them. Here we have option store metrics, and you can see and results pairwise correlation. And here you can see. And this is a correlation that you can see. This is the matrix. Sorry. And again, based on p-value, you can see. So this is this is pairwise. So TOEFL GRE. This is one relationship.
One correlation to the other one. Okay.
One, and this is p-value means it is useful.
Useful. Okay.
So you can see all of them, all are useful. Correlation means only 1-to-1 relationship.
1-to-2, okay.
One, correlation, you can see co means 2. So 2 variable relationship, and this is, you can see here.
Okay. Makes sense. Thank you for the explanation.
Yeah, most welcome. Effect type of Natalie? Can you?
Yeah,
please...
Natalie.
Natalie, sorry, I'm sorry. Yeah, please, can you elaborate your question?
Oh, sorry. No, I was saying, is it like a cause effect when you were?
Yeah.
Yeah. Okay.
So, for example, let's say, this is we did, this is, so let's say I'm just going to make a very simple model and regression. Fit regression, and let's say I'm just chance of admission depend on your GPA of and let's say so basically this is one more minute. So let's say, okay, here we go. This is the simplest, chance of admission depend on GPA. So this is regression, R square 77 something. So change in GPA impact chance of admission. So if high, you have high chance of admission, it is low. So this is causal relationship, means increase or decrease in this changes the outcome. And therefore, this is R square.
Got it.
Okay.
Thank you.
You're welcome. Any other question? If you don't have, then I would like to say wonderful evening, and we will meet next week, next Tuesday. If you have any question, comments, please keep sending the emails to me.
Thank you.
Thank you, Dr.
Thank you so much, Professor.
Thank you.
Thank
Good
you.
evening.
Thank you.
Good
Good
night.
night.
Bye-bye.
Bye.
Bye.
Good
Bye
night.
now.
Bye.
I do have a silly question.
Please, Christina, please.
Okay, so for the numbers, I noticed that you had some decibel numbers, there's some percentage numbers, there's some bigger numbers. And so for example, in your example, there's number of layoffs, which is a number, then there's percent, then there's dollar amount. So there's a lot of different kinds of variables. And I'm wondering if there's a preference on what kind of numbers to put in the data. Or I don't know. I don't know how to ask.
No. I mean, I would like to understand first, what is the, so I can explain properly. So this is related to discussion?
Yes.
Okay, so yeah, for example, here, look into this. You have, this is like, decimal point. This is, this is on 400 scale. This is, 300 something. This is categorical. So basically, you can, let's say, for example, salary of employee, this is salary. Salary, when you go for job interview, when you go for job job search, salary depends on number of factors. So salary, let's say this is in dollar amount, and your education level. Education is, you can decide undergraduate is 1 and master's is 2 or PhD is 3. So basically you can give, this different categories and you can give. Plus, it also depends on number of years of experience, So let's say you have 5 years, 7 years, you can give the numbers. So this is categorical 1, 2, 3. This is, in numbers on 1 to many years. Then other factors also, how smart, basically smartness, how you will judge, that on an interview, interviewer judge your smartness on 1 to 7 point scale. If they have 1 to 5 point scale, and different factor, based on that, they will decide your, salary. So basically, if you think it could be, for one person, this, for second person. So basically you can simply understand what factors are contributing in the outcome. Let's say, for example, layoffs.
So for my example, I work in education. And
Yes.
So when I was thinking about layoffs and what were contributing factors was the growth of online learning, cost saving, financial, college saving money, and enrollment decline. Those are some variables that I was thinking of.
Exactly.
So
okay. These are the very important. I mean, I'm in education and I can feel, I can observe and I can see. See, I mean, this is, let me not record this. So just please don't mind, you are in education.